Okay, this is my third take. First take was half an hour long, didn't like it for being that long. Second take ended up being 20 minutes long, still too long. And I didn't even finish that one, so let me try this third take and try to make it quick. Let's start with a situation that we're pretty familiar with. I've got this rod shape. I'm going to turn up the number of substeps, turn up the nudge exponent, and then let it reach equilibrium or something close to it. Let it drop. So this is just with the spring stuff. There's no damping. And so obviously we get this jiggling that we're really familiar with by now. If I fold it over, whoops, hang on a second. Let me turn up the nudge exponent a little bit. If I fold it over onto itself, you can see that we have some issues where things tend to go through and poke through inside out, kind of like this right there. That's no good. I'm gonna turn up the damping a little. Just a little. Not a lot, just a little. Do it again. Damping helps to stabilize things, but it doesn't fix the underlying issue. We still have things poking in through the geometry. It's going inside out, and it's not preserving the volume here as well as it should. You can see that self-collision is working. Clearly, this is colliding with itself, but it's not working well enough to deal with like this kind of portion of the geometry. So that's where the volume preservation, although technically it's area preservation in this case because we're in 2D, but it's, yeah. Let's bring that in and see how it does. Actually, we don't even need something crazy. Let's just go with that for now. The bounce came back. Interesting. Even with the damping, it still bounced. Now you can see when I fold it over, it's resisting poking through itself now. Oh, well, it still happened. I guess I didn't do it well enough. Let me turn this up a little more. It definitely was resisting it more, though. You could definitely tell that was the case. There we go. See, it's definitely resisting it. Let's see if I can get it to stay stable. Well, that's not good enough. Not good enough. Not good enough. Better. Okay, so now I've got this portion. It's attempting to preserve the volume there on that curved bit. Whoa, 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 whoa. Obviously there are still some issues with this though. Oh no, why is it doing that? Okay. My code, my method for volume preservation is not very good. Let me, it's got issues. Let me show. Let's try a square. I'm gonna turn up the size of the points though, just to make things a little bit more speedy. That's too much. Screw it. So one thing I'll notice now is if I were to spin this, for instance, even though there is a there's definitely something going on there where it wants to stretch it out. You can see instead of becoming like larger in volume, or in area rather, it stretches out thin. Oh, okay. That activated a feature that I implemented to detect when things have become unstable. It looks like I've made it too sensitive because that was perfectly fine. Let me do. There we go. Anyway, yeah. So in comparison, if I were to do something like that without the volume preservation stuff active. And then I gave it a spin, you would see that it would just keep getting wider and wider all around. Like that, yeah. Whoa, whoops. I gotta keep it up in the air. There we go, like that. Yeah, see, it's getting bigger. That is much bigger than our original shape. Another cool thing that we can do is just get rid of the spring stiffness altogether and just take advantage of the damping effect and then bring back in the area stiffness stuff, the volume preservation stuff. And the effect that has is we end up with something that kind of behaves like silly putty, you know? We are going to need a lot of sub-steps for this to behave appropriately, though. Well, actually, let's do 16. That should be fine. And there it goes. It's already starting to spread out. I'm going to put some pressure on it and see what happens. Wish. Wish. It has a flow to it. It behaves like a solid and a liquid. To make it tolerate... Whoa, there's an artifact. Okay, hang on. Don't do that. Thank you. To make it tolerate compression a little bit more, I'm going to turn down the nudge exponent ever so slightly. This will allow it to slide past itself a little bit better. And no, stop that. No, I said stop. Stop it. Stop. There we go. Okay, anyway. I just want this part to go down. If I could just get it to spread out more. Maybe if I turn down the nudge exponent more. See what happens. That might have been too much. Uh-oh. And it broke. Okay. What am I at right now? Okay, I've almost reached the 10-minute mark. I'm gonna wrap this up pretty soon here. Let's go to 7. Yeah, that's more like... actually that kind of reminds me of like, was it like polymer sand stuff? That's interesting. It's dimpling there. I wasn't expecting that. What's gonna happen? Uh-oh, I see an artifact forming. Yeah, that's no good. What's gonna happen? Uh-oh. What? Oh, there's another inside out bit there. Oh no. Uh-oh. Well, I guess this one is officially unstable. I'm not doing anything right now. It's doing it on its own. Again, I don't know if I said it already, I probably did, but my method for volume preservation is not the best. So yeah, it is important to have some springiness. With that said, this is definitely a lot better than not having any amount of volume preservation. It definitely behaves more realistically now to some degree. You know, we probably need a few more sub-steps. It just keeps going. Oh, it already is maxed out. Oh, can I fix this? Well, whatever. I think I made my point. I'm pretty sure I showed everything I wanted to show anyway. So, I am gonna wrap it up here. Thanks for watching. Have a good one.